going to continue working on the review for the quiz over chapter 5, sections 1 through 4, and then section 9. So we're going to pick up here on number 11. We are supposed to find all real and imaginary solutions of each equation by factoring. Now, even though it says that we're only going to use factoring, that may be a little bit misleading. We'll see as we get through it that to solve equations by factoring, that's plan A. Plan A is factoring. When factoring doesn't work and you have a quadratic equation, we're going to use a quadratic formula as plan B. You probably don't have that much room there. Anyway, I'm writing it there. So plan A is factoring, plan B is quadratic formula. So number 11. Remember that anytime we're factoring, always the very first step is going to be to look for a GCF. So in number 11, we start by looking for a GCF of these two terms. And what could go into both of those things? Yeah, an X. So what we're going to do is we're going to put that X in front of a parenthesis, and we'll be left with X squared minus 81. I want to tag along that equals 0 because we're solving an equation, not just factoring. So once we have the GCF out, then we want to go, okay, well, how many terms do we have in these parentheses? We have 2 terms. And if you recall, whenever we have 2 terms, I think I'll just go down here, 2 terms. Maybe I'll write first GCF. Then if you have 2 terms, then you're either going to be using the sum of squares, the difference of squares, sum of cubes, or difference of cubes formulas. So with sum of squares and difference of squares, those dudes start with either f squared plus L squared or f squared minus L squared, depending on if it's sum or difference. So when I work through sum and difference of squares, I want to see what times itself would give me that term, and I want to see what times itself would give me that term, because then I'm going to use those in the formulas as I go through. I'm going to take that f and that L, and I'm going to go in difference of squares, which we see most often, f plus L, f minus L. If I have sum of squares, it looks almost the same. But in sum of squares, I always just remember it's like save our ship, you know, like from sailing. And so on save our ship, then that reminds me, SOS reminds me of like SpongeBob. And what did SpongeBob always say? Aye, aye, Captain. So we go and add an I on there. So sum of squares has f plus Li, f minus Li. Difference of squares, f plus L, f minus L. Now sum and difference of cubes, sum of cubes is f cubed plus L cubed. Difference of cubes, f cubed minus L cubed. And what we're going to do is we're going to see what would multiply by itself f times f times f. Then that's what we're going to use in our formula. And what would multiply by itself 3 times, L times L times L. And that's what we're going to use in our formula for L. We would do the same things if it was difference. And then our formulas, these guys start with a binomial and then have a trinomial. So in the binomial, we go FL for both of them, FL. In the trinomial, we take f times f, and then f times L, and then L times L. That's for both of them, f times f, f times L, L times L. Excuse me. And then we're going to fill in the signs with soap. S means the same sign as the problem. So this is positive. We'd have plus. O is opposite. So opposite of that is minus. And then AP is always plus. So plus. Same, opposite, always plus. So let's do this one. Same sign, negative. Opposite sign, positive, always plus. There's your formulas. let's go get back to the task at hand, which was factoring. So with two terms here, I see I've got to use one of these formulas. It is subtraction. So it's either difference of squares or difference of cubes. That guy says squared, so let's do difference of squares. So I am going to break down x. What times itself would give me x squared? That would be x times x. What times itself would give me 81? That would be 9 times 9. So in the formula, this becomes f, this becomes L. So as I rewrite, then I'm going to go x from my greatest common factor times f plus L, so x plus 9, times f minus L, x minus 9. Still keep my equal 0. Now I have not yet solved solutions. Solutions means I have to know what x equals. So after I have it factored, then I'm going to set each factor that has a variable equal to 0. 0? Yeah. Set each factor with a variable equal to 0. So I set x equal to 0, x plus 9 equal to 0, and x minus 9 equal to 0. Then we solve for x. Well, this one's already solved. X equals 0 is one answer. This one we need to subtract 9 from both sides. So we get x equals negative 9. This one we need to add 9 to both sides. So we get x equals positive 9. So now we have found all of the real and there are no imaginary solutions to this equation. Moving on. X squared minus 4x minus 12 equals 0. Remember, what's our first step? If you said GCF, you're right. And if you said there isn't one, you're also right. So then after we see there's no GCF, we look and see how many terms. Well, this one has 3 terms. With 3 terms, we do the AC method. So we'll review that. I'm not going to write out the steps here. I'm just going to talk about it in this example. And then remind you that if you have 4 terms, it is factor by grouping. So back to my 3 terms. Factor by the AC method. So in the AC method, AC means I'm going to take the first thing times the third thing, which will be C, because it goes ABC. So I'm going to take the first thing, x squared, times the third thing, negative 12. And I get negative 12x squared. And what I want to do is I want to figure out a combination of terms that would multiply to give me negative 12x squared, but add to give me negative 4x. So one of the keys that you're looking for here is the sign of this dude up on top. If it's negative, like if this is, then the factors have opposite signs. If it's positive, then the factors will have the same signs. So this one's negative, so we'll go from there. So to get negative 12x squared, I could have x times 12x, or 2x times 6x, or 3x times 4x. Now remember, I want to add to get negative 4x here. So I'm going to choose the combination that has opposite signs and adds to negative 4x. So that's going to be 2x and 6x. In order to get negative 4x, my 2x has to be positive and my 6x has to be negative. So then I'm going to replace this negative 4x there. So I'll have x squared plus 2x minus 6x minus 12. And I want to keep that equal 0 along for the ride. And at this point, we start to factor by grouping, actually, because we have 4 terms. So we group these 2 together, and we're going to take out a GCF, and that GCF will be x. So then I'll rewrite that as x times, divide out an x from x squared, I get x. Divide out an x from plus 2x, I get plus 2. And then I look at my second group there, negative 6x minus 12. Now, whenever a group starts with a negative number, you need to take out a negative GCF. So rather than just taking out a 6, because those are both divisible by 6, I need to take out a negative 6. So I'll have negative 6, and then negative 6x divided by negative 6 leaves me with x. Negative 12 divided by negative 6 leaves me with positive 2. And I'm still equal to 0 here. Then I keep factor by grouping. I take the common parenthesis. That's going to be one of my parentheses. And then I take the stuff out front for my other parenthesis, so x minus 6, and I am equaling to 0. But wait, there's more. I still haven't solved yet, which means I have to set each factor with a variable equal to 0. So I take x plus 2, set it equal to 0. I take x minus 6, set it equal to 0, and then subtract the 2 over. I get x equals negative 2 here. Add the 6 over. I get x equals 6 here. And those are my 2 answers for number 12. On 13. 13. Hey, you know what I want to do? I kind of want to change this problem. Would you guys be okay with that? Since we're kind of watching it, doing this together. If I change this problem to 2x squared plus 18x plus 36 equals 0, would you be okay with that? Okay. So we'll start from the top. GCF. Is there a GCF? Yes, it's 2. So I put the 2 out front. And then what will I have left? I have to divide each term by 2. So x squared plus 9x plus 18 equals 0. Okay. Then I look to see, how many terms do I have? Well, there's 1, 2, 3. And so I'm going to be doing the AC method again. Coolio. I know how to do that. So I am going to take my first thing times my third. X squared times 18. That will be 18x squared. And I'm trying to add up to get 9x. Positive 9x. Okay. Now this time, unlike that one, this one was negative up there. This one is positive up there. And positive up there means the factors have the same sign as each other. So they'll either both be positive or they'll both be negative. In this case, they'll both be positive because I have to add up to get 9x. So let's list our pairs. I could have 8x times 18x, or 2x times 9x, or 3x times 6x. Which combination would add to give me 9x? Yes, this one right here. So then remember, I'm going to replace that 9x with the 3x and 6x. Keep your 2 big out front. So we'll have x squared plus 3x plus 6x plus 18 still equals 0. Now group. Out of this first group, I can take out an x. So I'm going to keep my 2 big and out front. So that will be x times x plus 3. Out of my second group, I can take out a 6. So that will be plus 6 times, you guessed it, x plus 3. Got to close my brackets, and I am still equal to 0. So now when I pull together these groups, I've got to remember the 2 out front from the GCF, my common parenthesis, which is x plus 3, and then my GCF parenthesis, which is x plus 6, and I'm still equal to 0. I still have not solved yet. When I solve, remember, I set each factor with a variable equal to 0. So remember on number 11 here, I had an x plus 9, x minus 9, and I set the x equal to 0 and all the other parentheses. This time my GCF has no variable. So we do not set that equal to 0. We're just going to ignore the 2 because it does not have a variable. So we ignore it. Then we just take the x plus 3, set it equal to 0, subtract 3, subtract 3. So x is negative 3. Take the x plus 6, set it equal to 0, and subtract 6 from both sides. So we get x equals negative 6. So we had 2 answers on that one. If we were not able to do the factor by AC method on either of these or this one, then what would our plan B have been? If we couldn't factor it to solve it and it had 3 terms, what would plan B be? The quadratic formula. And in case you don't remember that, it is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you remember that song, even though I did not sing it. Let's see what the next page holds in store for us. Ooh, it's backwards of what we just did. Write the polynomial in standard form with the given zeros. Okay, so back to here. These little dudes that we called solutions, x equals 0, x equals negative 9, x equals 9, those can also be called zeros or solutions or roots. So we're going to be working backwards. So we're going to start with these answers, put them back into their parenthesis form, then multiply them together to get all the way back up to a polynomial. Okay, I think we can do this. So we are going to start with the zeros or roots. We're going to put them back into their factored form. Then we are going to multiply it out to finally get polynomial form. Polynomial form is going to be our answer. Okay, so the 0 or root, I'm going to go x equals 3, x equals negative 8, x equals 0. Those are their 0 or root form. Now to put those back in factored form, I am going to bring that 3 over. So I get x minus 3 equals 0. Then I'm going to take this side here, this x minus 3, put it in a parenthesis and ignore the 0. So I'll do the same thing with x equals negative 8. I have to add the 8 over. So I have x plus 8 equals 0. So I'm going to put x plus 8 in parentheses. And then with x equals 0, like it literally already says x equals 0. So all I really have to do is have times x. That x could have been at the front just as easily as it is at the back, but I'm going to leave it where it is right now. Then we have to multiply out. So what that means for us is we would take these first two and multiply them by each other. So basically we're going to FOIL these first two together and go from there. So we'll have x times x squared, x times 8 plus 8x, negative 3 times x minus 3x, and negative 3 times 8 is negative 24. Now we're going to bring down this times x as we go. I might simplify what's in here, so I have x squared plus 5x minus 24 times x. Now, it's not in polynomial form yet, because to be in polynomial form, I can't have those parentheses and whatnot. So I am now going to have to multiply this parenthesis times this parenthesis. So basically what I'm doing is just distributing that x to all 3 terms. So I do x times x squared, I get x cubed, x times positive 5x plus 5x squared, x times negative 24, negative 24x. And then this is a polynomial in standard form right here. If they asked me for a function that had those zeros, I would have to do what? Do you remember? In order for it to be a function, it can't just stand alone by itself. It has to also have the y equals. So if it needed to be in function form, we'd have to tack on that y equals. But this one just said polynomial, so we're good with that. Okay, find the zeros of each function and then tell if it crosses or touches the x-axis. So I'm going to try and do something crazy here in a moment. See if it works. Things don't always work the way I want them to. So multiplicity has to do with the exponent. So the multiplicity is the value of the exponent. A 0 tells you x equals a number. And whether the graph touches or crosses, touches goes with, like it looks like that. It is an even multiplicity. Multiplicity, can't spell. Like it just comes down and touches like that. Crosses is an odd multiplicity. And it like goes through the x-axis. Because remember, zeros are x-intercepts, so this will be our x-axis. So if the graph touches, it doesn't cross through the axis there. It just like bounces off of it. So let's go through and identify our root, our multiplicity. I guess I should have said 0 because that's what the instructions say. But it means the same thing. So if I say root instead of 0, just know that it means the same thing. And then what the graph does. See if it touches or crosses. Okay. So we have to take each part of this that contains a variable and set it equal to 0. So I'm going to take x. I'm going to ignore the exponent for now. I'm just going to take the x, set it equal to 0. Well, I don't have to solve for x. It already says x equals 0. Then for the multiplicity, remember that is the value of the exponent. So the exponent on x equals 0 is 2. So the multiplicity there is 2. What would we expect the graph to do? Would it touch or cross? Even multiplicity, odd multiplicity. So we're looking at this number here is 2, which is even. So our graph would touch at x equals 0. It would not cross through. It would just touch. Okay, let's go on to the next little parenthesis there, which says 2x minus 3. Again, remember we're ignoring the exponent for now. So we're just doing 2x minus 3 equals 0. So we would add 3 over. So we get 2x equals 3. And then divide by 2. So we get x equals 3 halves. So that's my root, x equals 3 halves. That goes with 2x minus 3. The multiplicity, remember I'm looking at the exponent. So that multiplicity is 5. 5 is an odd number, so my graph is going to cross. Moving on to the next one. X plus 4. I did not leave myself enough room. So x plus 4 equals 0. Subtract the 4 over. I get x equals negative 4. For the multiplicity, I'm looking at the exponent. It has a multiplicity of 3, which is an odd number, which means my graph should cross. Okay, next, x minus 5. So x minus 5 equals 0. Add the 5 to both sides. I get x equals 5. For the multiplicity, remember I'm looking at the exponent. So here, multiplicity is 8. Now, the even and odd, I'm looking at the multiplicity, not the root. So pay attention to the 8. 8 is even, so my graph should touch. I guess I should say touches. So I'm consistent with my verb tense. And then my last one. The last one I have here has x plus 1. So I set x plus 1 equal to 0. Subtract the 1 over, I get x equals negative 1. Now, as far as multiplicity, I'm looking at the exponent right up here. There's no number there. So what is that exponent? It's not a 0, because if it was a 0, it wouldn't be there at all. So what would that exponent possibly be? Yes, it is a 1. So the multiplicity is 1. 1 is an odd number, so the graph should crosses there. Now here's where things are going to get a little weird. I graphed this on Desmos, so we're just going to look at each of those values. So I'll go in the order that it's shown here, but the weird part is I'm going to have to like move the camera and kind of show you. So ignore everything you see in the background. Okay. Here we go. So the first one that we talked about was x equals 0, and we said it would touch there. It's a little hard to tell, but you can see that I have an x-intercept there at 0, 0, and it's not crossing through, so it is touching. The next one we looked at was 3/2, so that's like 1.5. That's this guy here, 1.50. And we can see its multiplicity was 5. We said it would cross, and it does. Our next one was -4. -4, 0. Its multiplicity was 3. We said it would cross, and it crosses. Our next one was x equals 5 out here, 5, 0. And we said its multiplicity was 8, and it touches, which it does. It does not cross through, it just touches. And our final one was x equals -1 right here, -1, 0, and the graph does indeed cross there. So we did it. Trying to pause you here for a moment. It doesn't want to pause, so we'll just keep going. Our next one, we are going to divide using long division. Okay, I did figure out how to pause it eventually, but now we're back. So long division. If you are one of my kids, you will not be surprised when I start singing you the long division song. Well, I'm not really going to sing the song, but it's how I remember how to do long division. It goes divide, multiply, and subtract. Bring it on down. Now bring it on back. Divide, multiply, and subtract. Bring it on down and bring it on back. So I am going to write out the steps. Then I'm going to explain the steps. Then we're going to do the steps. And then you'll know how to do long division. Yay. So divide. The divide step means that we are going to put the first term of the dividend over the first term of divisor. Oops. And I will definitely be showing you this as we go, so no need to worry. Multiply, you're going to take what you got in the divide step, and you're going to multiply it, distribute it into the divisor, which you are going to put in parentheses. Then on the subtract step, you're going to change your signs because adding is easier than subtracting. So we change signs and add instead of subtracting. But I still say the subtract line because that reminds me to change my signs. And then bring down the next term. And then the bring it on back means we go back up to the divide step. So we do divide, multiply, and subtract. Bring it on down. Now bring it on back. Before you start doing your long division, you need to make sure that you get things set up appropriately, meaning that the dividend goes inside the hut, the divisor goes outside, and you have to be in standard form, which means we go 3, 2, 1, none, or 4, 3, 2, 1, none, or 2, 1, none, whatever. You don't want to have any missing spaces. If you have missing spaces, please use a 0x to the whatever power to fill in those gaps. And that's how we go. So the dividend goes first. The dividend goes first, and then we divide by the divisor that goes outside. So a division problem is written in that order. The dividend, which goes inside, divided by the divisor, which goes outside. So we're going to have 2x cubed minus, whoa, that's a 3, 3x squared, minus 18x minus 8 goes in our dividend. Our divisor is this x minus 4. And now we are ready to do our long division steps. So we do divide. We're always taking the first term over the first term here. So we do 2x cubed over x. You can't see that. 2x cubed over x. And then we simplify that. 2x cubed over x would simplify to 2x squared. Now, this 2x squared becomes a part of our answer. So a lot of times I'll circle it so I don't forget it, because sometimes I forget to write it up there. So at least at the end I have all of my quotient circled. BT dubs, this up here is the quotient. Okay, moving on. That was the divide step. The multiply step is to take what you just got, and for simplicity's sake, I usually just write it right next to it there, times the divisor that I put in parentheses, so times the x minus 4. Now what I get from that step is going to go here. So I'm going to distribute 2x squared times x is 2x cubed. 2x squared times negative 4 is negative 8x squared. Please pay very close attention to your signs when you are doing this process. So that was the multiply step. So divide, multiply, and subtract. Subtracting, we change the signs. So I am going to change this sign here, change this sign here. And again, I circle those mostly as a visual cue to myself to make sure that I remembered to do it. So divide, multiply, and subtract. So we add these together. We planned it out so that these two terms would cancel, and then these two terms combine. So I have negative 3x squared plus 8x squared is 5x squared. So we now have done divide, multiply, and subtract. Bring it on down means I bring down the next term, so minus 18x. Now bring it on back means I'm back at the divide step. So divide, take the first term over the first term. So 5x squared over x, which gives me 5x squared divided by x leaves me with 5x. Hey, 5x is part of my answer. I'm going to circle it and I'm going to write it up here. 2x squared plus 5x. Multiply what you got times the divisor. So 5x times x minus 4. That answer is going to go right here. Distribute that through. 5x times x is 5x squared. 5x times negative 4 is a negative 20x. Divide, multiply, and subtract. Change the signs. Now add them together. Notice that these first two terms cancel each other out. We did that on purpose. And I add these guys together. Negative 18 and 20 gives me a positive 2x. Bring it on down. Now bring it on back. Divide. Multiply. Subtract. And look at that. We have a remainder of 0. So that little dude at the end, if there is a number left and not a 0, I mean, I guess technically 0 still is the remainder. That is the remainder right there. So the quotient is the answer. The remainder is the last thing we get after we have brought down the very last term and gone through the divide, multiply, and subtract steps for the last time. So in this particular case, our answer would be 2x squared plus 5x plus 2 with a remainder of 0. Okay. Now synthetic division. I do not have a song or rap for synthetic division. I don't even have steps I can write out because the steps are more confusing to write out than it is to just do the synthetic division. But one thing that is mucho importante with synthetic division is using the space holders. If you do not use the space holders, you will get the wrong answer. Don't do that. So the space holders are needed if we go, remember we go 3, 2, 1, none. That one doesn't need a space holder. This one goes 4, 2, 1, none. What are we missing? All right, we're missing 3. So we're going to have a space holder there. With synthetic division, what we're going to do is we're going to take the dividend and we are going to write only the coefficients. So what's the coefficient on the x cubed and the x squared? They are both 1s. So we go 1 for the x cubed, 1 for the x squared. What's the coefficient of x? Negative 16. And what's the coefficient of none? Also negative 16. So the coefficients of the dividend go in that first row. Then we take our divisor and set it equal to 0 so that we get x equals 4. So what x equals is what goes in this box over here. So we don't put x minus, wow, that should be a 4. I don't know how that happened. We don't put x minus 4 in there. We put 4 because that's what x equals when we're using x minus 4. Okay, so far so good. Now for the synthetic division part, I usually put a little line here because this box right here is going to be my remainder. And what I get here is going to be my quotient. So for the synthetic division part, I am going to always take my first term and just bring it straight down. So that's going to be a 1. And then when I go diagonally into this next box here, I'm going to take the 1 times the 4. 1 times 4 is 4. Then I'm going to add 1 plus 4, and I get 5. Now I do it again. Multiply. 5 times 4 is 20. Add negative 16 plus 20 is 4. Go again. Multiply. 4 times 4, 16. Add negative 16 plus 16 is 0. So I kind of misled you a little bit. This is not actually the quotient. It's what helps us be able to write the quotient. So since our dividend started with a 3 and then a 2, then a 1, then a none, our quotient is going to be 1 less than that. So it is not going to go 3, 2, 1, none. It is going to go 2, 1, none. So this 1 is going to be attached to an x squared. 5 is going to be attached to x, and 4 is going to be attached to none. The remainder is 0, so that's cool. So technically our quotient would be x squared plus 5x plus 4, and our remainder would be 0. Let's see how number 18 plays out. We're going to do synthetic division again. This time, our dividend goes 4. We don't have a 3. X cubed, where are you? You're missing, so we're going to go 0. And then 2, 1, none. So our dividend row has a coefficient of 1, and then 0, and 3, then another 1, and then a 4. Our divisor, remember we take x plus 3 and set it equal to 0, so that we get x equals negative 3. The x equals part is what goes in the box. X equals negative 3, so negative 3 goes in the box. Then we draw this fancy thing with the box to isolate the remainder. Then we're going to go through those same exact steps again. So the first thing we do is bring down the 1. It's not always a 1, but it has been in these two problems, so that's weird. Then going up here, we multiply 1 times negative 3, which is negative 3. Then we add those two straight down. 0 plus negative 3 is negative 3. Then we're going to go again. Negative 3 times the number in the box, which is also negative 3, would be positive 9. Then we add these two numbers, 3 plus 9, 12. Move over. 3 times negative 12 is negative 36. Add those numbers straight down. We get negative 35. Oh, mercy. Then we got to multiply negative 35 times 3. I hope I did this problem right. These are big numbers. That's 15. I think it's 105. Okay, so that is positive 105. Then we add, going straight down, so that would be 109. Now remember that this dude here is the remainder. This dude here tells me the quotient, which is the answer to a division problem. Since my dividend started with a 4, it went 4, 3, 2, 1, none. This one is not going to start with a 4. It is going to start with a 3. So it's going to go 3, 2, 1, none. So it will be x cubed with a coefficient of 1 minus 3x squared plus 12x minus 35. That's going to be my quotient. And my remainder is going to be 109. Okay, next one. We are going to use synthetic division again, but for a different purpose. It doesn't tell me to divide. It says use the remainder theorem to find P of 5. So we're going to do the exact same steps that we just did, except for this is telling me x equals 5 already instead of x minus 5, which the other things did. So in this case, we're going to take our coefficients, 3, 2, 1, none. So I don't need any placeholders. So I'll go 1, -7, 15, and -9. Now remember what goes in the box is what x equals. Well, this time they told me what x equals. So I don't even have to change the sign of that. I just take the 5 and plug it right in there. So you don't change the sign when you're doing synthetic division with the remainder theorem. So that's cool because they already told me x equaled 5. Then we're going to do the same thing. Now, the answer to a synthetic division problem is going to be right here in the remainder. That is going to be what P of 5 equals. P of 5 is going to equal what we get for the remainder. So now it's just a matter of running through synthetic division. So remember, the first number comes straight down. So 1, multiply diagonally, 5, add down, -2, multiply diagonally, -10, add down, 5, multiply diagonally, a 25, and add down 16. So P of 5 would equal 16, and that is what your answer looks like on a synthetic substitution or using the remainder theorem type of a problem. Make sure that you get all of this good information onto your cheat sheet and get ready for that test next class period.